I divided the presentation into two segments. In the first section, we're going to take a general look at the neonicotinoids. And then in the second section, I'm going to move more specifically to talk about citrus and the use of neonicotinoids on containerized citrus. So both Jim Bethke and Beth Grafton-Cardwell referred to this poster this morning in their talks, and this is basically IRAC, or the Insecticide Resistance Action Committee's effort at classifying insecticides based on the mode of action. So every insecticide that you can think of should really be there. And the neonicotinoids are group 4A, acetylcholine receptor agonists, and they're in a group all on their own. This poster is actually downloadable if you want from iraconline.org. So if you want to get your own copy, or there's probably a later version of that available now, so check that out. The neonicotinoids themselves can be classified even further based on the kind of the year in which they were developed, or at least the lead compounds were developed. It's not going to get too complicated, I promise, but there are essentially 3 generations worth of neonicotinoids, which began really with imidacloprid, and then they've worked their way through two further generations, and the representatives of those generations that I'm going to speak about today are imidacloprid. Admire Pro is the formulated product I'll be talking about. Thiamethoxam, flagship, and dinotefuran, formulated as Safari. Some of the favorable attributes of neonicotinoids before we get into some specific data. Generally, it's of course a distinct mode of action, and this has the advantage in that it allows us to manage our resistance more effectively by rotating. There are foliar and systemic formulations available for many of the neonicotinoids. Today we'll exclusively talk about the systemic versions. I guess the choice of whether you're going to choose foliar versus systemic really depends on whether you want a short-term residual type of effect on your crop, a quick cleanup or whatever, versus a more persistent type of control. And that will become more evident when we discuss some of the data. So, in relation to the systemic activity, of course, neonicotinoids are applied when they are applied systemically to the soil. They're absorbed through the roots and then transported around the plant in the vascular system, initially in the xylem, and then from the xylem they'll move into the phloem. So this particular mode of application, or mode of activity, I should say, allows for a better delivery to plants for pest management and obviously for sucking insects. Because it directly exploits their feeding behavior. So both xylem feeders such as glassy-wing sharpshooters and the phloem feeders such as Asian citrus psyllid or whiteflies aphids, these are perfect targets for the neonicotinoids if you can get the insecticide into the plant at a sufficient level to be effective. There are a range of delivery systems. I'm not sure how relevant this particular part of the slide is. The objective of the delivery system, of course, is to get the material into the plant so you can actually get some efficacy. I do a lot of work in the field, and so there are various sprinkler, drip, and soil injection systems. I'm not sure how relevant they are to the indoor situation, but we had a speaker this morning. Obviously, there are some situations that are similar, and of course, this is probably totally unrelated. We do have trunk paint and trunk injection options in the field as well. And another favorable attribute is that even though they belong to the same class, there is a distinction that can be drawn between the different neonicotinoids in that no two neonicotinoids are the same, thanks to their chemical makeup. And we can actually exploit those chemical properties to good effect to tailor certain pest management situations. Perhaps the most important aspect of their chemistry is their water solubilities. They can vary quite extensively in that property. And in conjunction with other chemical properties, which I'm not going to go into any great detail on, they also vary in their interactions with soil and potting media components. Okay, but I want to talk just a little bit about the water solubility of the neonicotinoids now, and this is one of the key exploitable features of the systemic neonicotinoids, and one that I'll show you some data to demonstrate what I mean by that. These are the water solubilities of the 3 insecticides that I mentioned. So we have Admire Pro, Flagship, and Safari, for those of you that are more familiar with the trade names. Essentially, imidacloprid is the least soluble of those 3. You can dissolve half a gram of material just about in 1 liter of water, versus up to 40 grams of dinotephurin in the same volume of water. So it's quite a considerable difference between the 2. And in terms of that water solubility, this really affects how they behave in the soil or potting media. And generally, as a general rule, I'm not going to say that it's hard and fast, but as a general rule, in terms of the rate of uptake, in other words, the time between when you apply your material and the time when it actually manifests itself within the plant, that speed or that rate is much faster with the more soluble compounds. And you can kind of think of it in terms of if you absorb 1 mil of water under different conditions, if you have half a gram versus 40 grams of insecticide, 2 different insecticides, you can appreciate how the uptake can actually be a lot quicker with the more soluble compound. In terms of persistence, though, this can work in the opposite way. And generally, with the more soluble compounds, you can get a faster influx into the plant, but as a consequence, the reservoirs that might be present in the pot or within the plant itself might deplete more quickly. And just to illustrate exactly how you can actually see this, this is the way I use to demonstrate. You can take different, these are glass columns with a little frit on the bottom so the soil can't pass through. You can put different types of soil in these glass columns, and then you can add insecticide to the top of the soil and then wash it through with continuous washes of water. And you can collect the insecticide as it comes through the bottom of the column. So in this particular one here, we add whatever insecticide, imidacloprid, and then we continually wash it with water, collecting fractions of the wash as we go through, and then we can quantify the insecticide in the material that passes through. And it's just, I did say no 2 insecticides were the same, and this is data for, let me just pass that by. This is data for 2 organic mixes. I'm not giving trade names to these because I can't actually remember which 2 they were, but they were essentially the same. They were almost 100% organic matter. And the red line is the line representing dinotephurin for both the 2 organic potting media, and the blue line represents the response of the imidacloprid. And essentially, at time 0 here, this represents our wash number. So before we do anything, before we add any insecticide to the column, obviously there's nothing there. As soon as we add the material, there's actually almost immediately the dinotephurin, because of its greater solubility, it washes through even the high organic matter content soils. Whereas imidacloprid, which has a greater binding to organic matter, is actually retained in the soil much more effectively. So the point I want to make, you can kind of misinterpret this data, I guess, depending on how much water you use to water your plants. But the water solubility will have a major effect on the movement of water through your pot. You can essentially equate the pot with those glass columns. So if you overwater, you can essentially see how quickly the material could actually leach through the pots. And my second point is that, with careful use of irrigation water, you can probably optimize an insecticide application and provide better control. Because even though we're looking at uptake of imidacloprid is very, very slow through the soil, it's retained within the soil and therefore it's available for uptake, provided it's not bound too tightly to the organic matter. In contrast, if you add water to the pot or the column, you actually have a lot of dinotephurin that's been solubilized, and therefore it's available for uptake through the roots. However, if you overwater, it can end up, outside at the bottom of the pot and out of the root zone. So that's just kind of, and just to show a real live example of what exactly this would look like. And this is a study that Jim and I did on poinsettias a few years ago now. And I do have the trade names here. Okay, well, not to worry. So these two lines here, the red and the green, represent the two organic potting media mixes for imidacloprid. And the same too with dinotephurin. Now this particular application, even though the label rates for dinotephurin for safari are higher than imidacloprid, we did equate the amount of material that we put into the pot. So we were doing a kind of a pound for pound measure of the materials. And once again, with the greater solubility of the dinotephurin, we saw a much faster uptake. And we manage the water into these because we're doing this study in a greenhouse, so we can add a finite amount of water to avoid any leaching. So we were able to get a much more rapid uptake of the dinotephurin into the poinsettias compared with the imidacloprid. And the imidacloprid, you can see, it moves much more slowly, and when it peaked, it was 56 days later. This is not bad uptake here, by the way. It's just trying to demonstrate the difference in water solubility and how that can kind of manifest itself in an actual plant. And not in this particular instance, no. But I did mix the UCR soil, which is one of the UCR mixes, with, I don't recall which of the sunshine or the pin strip I used, but we mixed the organic, in fact not in this particular slide, let me just move on. Actually, I just used the UCR sandier mix on its own. There are no mixtures on this, I beg your pardon. On this particular case, the sandier soil, when we watered, we got very rapid uptake with the dinotephurin, seen here with the dotted line, and then with the blue line, you can see how the imidacloprid. So this is the data. These lines here, the lower lines, are the same data as on the previous graph. But when you have a sandier soil, you can actually improve the uptake of the imidacloprid, making it more available to the roots. But at the same time, with the dinotephurin, because it's more porous and less binding, you do see a quicker drop-off in the concentrations that are available for uptake. Right, yeah, so we would take new leaves, leaf samples at those sample dates, so at week 7, at week 1, 2, 3, 4. So sure, it's cumulative, yeah. So in other words, at 21 weeks, the concentration of imidacloprid in the plant is 1,500 parts per billion in the leaves that we sampled from those plants. Not in the soil. I mean, you want to get it into the plant, though, from the soil. Or whatever your insect pest is. We're talking about whiteflies here. In this particular instance, the units are in per leaf disc area. So I'm not sure how that equates to a nanograms per the parts per billion. We need 200 parts per billion in a plant, in a citrus tree, for a leaf miner. That's published data, yeah. You know, I'd have to do a weight of a leaf disc. This is demonstration purposes only, okay? All right, so that's what I want to leave that. That's some general information about the neonicotinoids. I thought you might find that interesting. I want to move on now to talk a little bit about the neonicotinoid use on containerized citrus, and I want to present some data from a number of trials that we've been conducting over the last couple of years, thanks to funding from the CCMB and the CRB. So I'll present some of that data. Let me just introduce a few things first. So in terms of agent citrus psyllid control, the concentrations of imidacloprid that we require in tissue that insect may feed on are 200 parts per billion. Now, I didn't derive this value. This was derived by a researcher in Texas A&M, Mamadou Setemu. We don't really know the concentrations for thiamethoxam and dinotefuran. But when we do our trials, we certainly wouldn't want, I think, to have less than the 200 parts per billion. We can at least, from our experiences with other insects, if we can get 200 parts per billion of those insecticides into the plant, then at least we might be making some progress in terms of, making a recommendation about, well, not a recommendation, a guideline on whether or not they might be effective. But as yet, that data for thiamethoxam and dinotefuran needs to be derived. So when we do our trials, we'll collect the smallest leaf tissue that we can get, the youngest leaf tissue, which is favored by the agent citrus psyllid for feeding and oviposition and nymphal development. So Mamadou Setemu again has graded the citrus according to these different sizes. So we'll look for this if we can get it. We'll mash that material up in a tube, a known concentration, a known weight of material, and we'll do an extraction, we'll do a purification, and then we can quantify the imidacloprid that's actually in the leaf tissue. And if we collect if we collect leaf tissue from whatever tree, whatever plant, and we conduct bioassays on that same leaf tissue, we can equate concentrations of whatever insecticide we're looking at, in this case imidacloprid, with the mortality of the insects that actually fed on that leaf tissue. Okay, so in terms of the project that we were doing over the last 2 years, it was born out of the Florida situation and, of course, the introduction of ACP into California. And as Beth told us earlier, is the retail market that really contributed to the distribution of the ACP and subsequently HLB in Florida. And in our efforts to be proactive here, we're using quite a lot of pesticides, most notably, of course, imidacloprid, in an effort to kind of circumvent the spread of the psyllid in the same manner. In terms of the quarantine now, and thankfully Beth has gone over all this, so I don't need to. I just need to basically read the slide because you've already got it described to you earlier. The current quarantine requirements are that plants be treated with the maximum label rate of, at the time it was imidacloprid, before shipping to retail outlets. So plants at production nurseries would have to be treated with that systemic insecticide, in addition, of course, to the foliar treatment. And there were concerns within the industry at the time about the persistence of imidacloprid treatments on containerized citrus, and Byrne, of course, proposed raising the level, and Beth described this this work to you this morning. They have now raised the Admire Pro rate from, instead of being 0.33 mils per cubic foot, it's now 0.33 mils per 0.1 cubic foot. So it actually was raised at least tenfold in level. In fact, it was 3.3 to 5 mils. In fact, it was up to 5. So a 10 to 15-fold increase represents quite a substantial economic burden on a nursery. So our role really was to evaluate the pesticide application rates on containerized citrus to see exactly how well they were doing. And the certification period for the pesticides are 3 months for each of the 3 neonicotinoids that are recommended as systemic treatments. A lot of formulations available. I'm not going to count them either, Beth. We have one thiamethoxam and one dinotefuran that I'm aware of. There may be others. I have most data that I'm going to present today on imidacloprid, and then I do have some data in my final slide for thiamethoxam and dinotefuran. And of course, the deal is that at the production nursery, seen here in the middle, we want the production nursery must treat with that systemic insecticide, and before it reaches the home via the retail outlet, we would like to ensure that the concentrations of insecticide remain high enough by the time they get to this stage to prevent any kind of transfer of the psyllid, either within the quarantined area or in fact beyond. So that's what this is. This is supposed to be dark green in the middle and lighter green as the imidacloprid dilutes its way from source to sink, as it were, to its final resting place. So the imidacloprid treatments are conducted at the production nursery, so it's very important that we have good applications at this site. And there won't be any treatments at retail outlets for, I think, for very obvious reasons. It's just not feasible. And so we really are looking for the 3 months protection required from the nursery, from those nursery treatments. Trial number 1, we looked at the impact of application rate, and also there was a rootstock component to this as well on the uptake and persistence of Admire Pro treatments. The mandarins we used were Mineola tangelos budded on Chorizo and Macrophylla. They were 2 years old at the time of the experiment. And we evaluated, because of the limited number of trees that we had available to us, we evaluated the old rate, the 0.33 mil per cubic foot rate, which is the kind of the standard rate for most of in fact all of the imidacloprid formulations except Admire Pro. Admire Pro has this rate on its label, but it also has this higher rate now. And I just want to remind you that the target threshold for ACP was set by Mamadou as 200 parts per billion. This is the data that we have for that trial, and we ran it out over 24 weeks, so we have 6 months worth of data here. And I've set it on a linear scale just initially. I will put it on a better scale in a minute, but just to show you the colossal amounts of insecticide that you can get into a tree if you apply the 5 mil rate. We're up to over 250,000 parts per billion. This is parts per billion, and we need the 200 part per billion rate is down here. You can actually, it's squashed up against the x-axis. I just wanted to make a point that it did look like there was some kind of separation between the two rootstocks, but I don't really need to make that an issue today. This is a log scale on the y-axis now. It kind of brings everything more into perspective, and we have the lower rate here for both the Chorizo and the Macrophylla trees. And again, you can see even on a log scale, the great separation there is between the two rates. But what we did find was that it took, in this particular instance, 3 to 4 weeks before the material established at the lower rate at the target threshold for ACP control, the 200 parts per billion. However, once it did establish, we easily got 3 months control after that period. And at the 5 mil rate, we certainly got more rapid uptake at that rate, and the thresholds were reached within 1 week. But of course, you saw the exorbitant amount of material that was actually present in the trees, at their peak. So with both the 5 and the 0.33 mil rates, we did get excellent persistence once the material was established in the tree. And I just want to make the point at this stage is that with the 0.33 mil rate in that instance, it just shows how important the foliar treatments are at the time of shipments, because those foliar treatments could be necessary to protect the trees while something like imidacloprid is establishing itself within the tree. So you may need that 2 to 3 weeks of protection from the foliar treatment. And we did see a more rapid uptake observed in the Macrophylla trees. I'm not sure whether that's real or not. It did happen in this particular instance. Let me move on now to trial number 2. This was a trial conducted with W. Murcott mandarins Again, 2-year-old trees. We also evaluated the 0.33 mil and the 5 mil rate as before, but we also included 2 intermediate rates. So we had a kind of a nice log linear sequence of rates to compare. And these are the results for that particular experiment. And again, we're at week 16 at the moment. I'm not sure whether it's going to go any higher, but certainly we didn't see the 250,000 parts per billion peaks, but we at the high application rate. But we certainly got colossal amounts again at that 5 mil rate. That's why I show this particular graph. But if we put it on a log scale, just to bring everything into perspective, in this particular instance, we got targets reached within 1 week. So there's definitely going to vary it looks like it's going to vary from situation to situation. But at all the application rates we used, the material was at the ACP target level, 200 parts per billion, within 1 week, and maintained for at least 3 months after that peak, after that target was reached. Did I what? No. The Mineola Tangelo project, or the trial, that was run from February through to whatever the 6 months period was, and so it was probably slightly warmer during that trial. The Murcott trial was started in November, so the temperature would have been cooler, so it may account for that, for sure. And it may also relate to the Murcotts were on chorizo, I think, which is a trifoliate derivative, and I think there may be some kind of dormancy associated with that particular rootstock. So there may be an impact of the rootstock on that. I'm not totally sure. I'd have to refer to the industry experts on that, but it's a possible explanation. Okay, let's move on then. I showed this earlier, and of course we saw that there was Flagship and Safari were also listed on the systemic products table. And so I conducted a trial. This one's ongoing at the moment up at Lynn Cove Research and Extension Center. And we're evaluating the label rates of Flagship and Safari and the low rate of Admire Pro on Kino and Tango trees that are both budded on chorizo. So this trial is going on at the moment, and I only have data for the first week, I'm afraid, but I did want to show it to you ahead of time. And basically, so we have the 3 Kino sets of Kino trees on the left here, and on the right we have the Tango trees. And again, the 200 part per billion threshold here is for imidacloprid. I just wanted to show that within 1 week after treatment on these trees, we were able to get the material in at very, very substantial levels. The very, very soluble dinotefuran wins the day in terms of week 1 levels. I'm not sure how persistent it will be, and I think that's obviously something that we're going to have to. Well, we're obviously going to have to wait and see, but it'll be interesting to see and how that manifests itself over time. All right? And I want to acknowledge the funding from both the CCMB and the CRB. It's been fantastic working with them and people within the industry, particularly Don Dillon, who provided us with the trees and for the experiments that I showed you. And also want to acknowledge Beth and her staff, in particular Therese Capon, who does all our sampling at the station and then ships the material down to us. So that's a very, very big help to us to have that work done for us. And I'll leave it at that. Thank you. The second part of the question, in terms of if the soil dries or the potting media dries and the material becomes bound to the organic matter, the Bayer scientists say that's it. you can kiss it goodbye. And we see that in the field a lot, because when we apply the material to soils with high organic matter, if the duration between successive irrigations is if the frequency of irrigation is too wide, then and the soil dries, then you basically are not really going to get very, very effective uptake. And the first part of your question, I think it depends on the root structure. In our particular case, the poinsettia study, we got a very, very nice result for both dinotephurin and imidacloprid, and I think that was because the roots, which are also organic, they can bind onto the material and absorb the imidacloprid. So if the root structure is not very good in the soil, I think you have a greater opportunity to lose it. That's the best answer I can give on that. Yeah, but my point is that if you go to an avocado grove and where you have this absolute massive humus under all the trees, it's in a mature grove, and you apply your material to that and I let it dry, that material is gone. Neither love nor money will get that back. In the situations you're describing, you're not talking about soils that are 100% organic matter. You're talking about maybe they could be 20% organic matter, in which case you can retrieve it for sure. There's no doubt. In fact, probably less than 20% actually. That's probably a worst case scenario. Yeah, I'm happy to comment actually. You can actually see a discrepancy between perfect laboratory data as displayed here and the real world situation, and that's why in addition to in addition to our being able to monitor every condition in the greenhouse, I find that when we're monitoring in the field in the nurseries, that the flushing cycles are more, or the flushing is a lot more intensive, and in fact when I did my sampling, you do get a lot more dilution of the material due to the production of new foliage. So there is an actual time delay, and again, there wasn't time to really go into that, but as the material, imidacloprid in particular, has been taken up, it actually moves slowly within plants as well. And when there's a new flush, this is of course going to be the problem we have in the spring and fall flushes in the commercial groves. When the trees are flushing at those times, when they're flushing aggressively, if we get the material into the trees, there will actually be a time lag between when the material, between when that flush appears and when the material can actually be established at effective concentrations. And I think in relation to the nursery situation, this is the key is, of course, to have that foliar treatment to protect the flush while the imidacloprid is establishing itself within the tree. But certainly we get really, really high rates, and in fact I have data. I did some work with Roger Smith at Tree Source. I mean, I didn't include that slide on here, but again, that's another nursery where I did some monitoring, and we can get values not quite as high as the 250,000 parts per billion, but with his application, we were in the 1,000 parts per billion range, and actually higher. So it's there's going to be a lot of variability in it, Phil.
All right. Thank you, Frank.